From the depths of our planet to the surface, hot molten rock called magma rises. When it reaches the surface, it erupts as lava, ash, and gases. These eruptions can build new land or destroy entire cities in an instant. They are volcanoes. But how do they work? What forces cause them to erupt? And what happens when they blow their tops? Let's find out. Number 12. The building blocks. Imagine the inside of the Earth as a giant layer cake. Each layer has a different name and a different temperature. The outer layer is the crust, and it's relatively cool compared to the layers below. Beneath the crust is the mantle, which gets hotter the deeper you go. And then there's the core, which has two parts, the liquid outer core and the solid inner core. The inner core is so hot that its temperature reaches about 5,000 degrees Celsius, which is as hot as 9,000 degrees Fahrenheit. That's really, really hot. Now, this temperature difference between the core and the crust creates some serious heat, and where there's heat, there are hot, gooey rocks called magma. This magma is less dense than the solid rock around it, so it starts to rise. It's like trying to push a beach ball under the water. It just wants to float to the top. As the magma rises, it collects in chambers beneath the crust. These chambers are like giant balloons filled with hot, bubbly magma, but as more and more magma collects, these balloon-like chambers start to stretch and thin the crust above them. Eventually, the pressure from the magma is too much for the crust to handle and it breaks through in a volcanic eruption. It's like when you blow up a balloon too much and it pops. Number 11. Plate tectonics. Most volcanoes form along the boundaries of tectonic plates. These are the giant slabs of rock that make up the Earth's crust. And they're always moving, crashing into each other, pulling away from each other, or sliding past one another. Where these plates meet is like a giant earthquake waiting to happen. And that's because the edges of these plates can get pretty rough and jagged. And when one plate gets stuck, it builds up a lot of pressure. And you know what happens when you build up a lot of pressure? Boom, an earthquake. And when that happens, it can trigger a volcanic eruption. It's like when you wiggle a balloon and it pops. But plate tectonics doesn't just cause volcanic eruptions, it also builds mountains. When two plates collide, the weaker one often gets pushed on top of the other, and over millions of years, this can create entire mountain ranges. It's like when you play with clay and push it up to make a sculpture. The difference is these sculptures are way bigger and way more epic. Number 10. Subduction zones. Picture this, two plates of rock colliding, one is oceanic, the other continental. The oceanic plate is like the bully, and it dives beneath the continental plate. This process is known as subduction. So at subduction zones, one plate gets literally swallowed by the other. And as it sinks into the hot mantle, something amazing happens. The intense heat and pressure turn the ocean plate into a super dense rock called eclogite. Ectolite is so heavy that it plummets deep into the mantle. And as it goes deeper, it releases fluids like water and carbon dioxide. These fluids act like a lubricant, making the mantle hot and gooey. And guess what? Magma forms. This magma is so buoyant that it just floats back up toward the surface, creating mountain chains like the Andes and the Mariana Islands. Number 9. Hotspots. Ever heard of a hotspot? No, not that kind of hotspot, although that could be pretty cool. I'm talking about a volcano hotspot. A hotspot is a region where magma comes from deep within the Earth's mantle. It's like a giant underground geyser, and as the magma rises through the crust, it creates a mountain. As the plate moves over the hotspot, the mountain gets built higher and higher, but eventually the plate moves away from the hotspot and the magma supply cuts off. At that point, the mountain building stops and a new plate moves in, and the process starts all over again. This is how we get chains of volcanic mountains like Hawaii. Each island is a testament to the power of a hotspot. Number 8. The Ring of Fire. There's a place on Earth where volcanoes and earthquakes are a way of life. It's called the Ring of Fire, and it stretches for about 40,000 kilometers or 25,000 miles. The Ring of Fire is where 4 of the Earth's tectonic plates come together: the Pacific Plate, the North American Plate, the Eurasian Plate, and the Australian Plate. And when these plates meet, they don't always get along. They crash into each other, pull away from each other, and slide past each other, causing earthquakes and volcanic eruptions. In fact, about 75% of all volcanoes are found along the Ring of Fire. Places like Japan, Indonesia, and the Philippines are in the unlucky spot of having multiple volcanoes nearby. It's like living next to several powder kegs, and when one of those kegs goes off, it can cause massive damage. For example, in 1815, Mount Tambora in Indonesia erupted. It was one of the most violent eruptions in history, and it caused massive damage in the surrounding areas. Number 7. Explosive eruptions. Volcanic eruptions can be explosive or effusive. Explosive eruptions happen when the magma contains a lot of gas. As the magma rises, the pressure drops, causing the gas to expand and explode. Think of a shaken bottle of soda. When you open it, all the gas inside comes rushing out in a big fizzy explosion. Similarly, a volcanic eruption can send ash, rock, and gas high into the air. This ash can travel for hundreds of kilometers, blanketing entire regions in a layer of dust. But explosive eruptions aren't always big. Some are small and can happen frequently. For example, Mount Vesuvius in Italy, which erupted and destroyed the Roman city of Pompeii, had many small explosive eruptions before the big one. Number 6. Effusive eruptions. On the other hand, effusive eruptions are non-explosive and happen when the magma doesn't have much gas in it. Instead of exploding, the magma just flows out of the volcano. This type of eruption is less dangerous but can still cover large areas in lava. In 1707, Mount Unzen in Japan had an effusive eruption that sent a river of lava 7 kilometers or 4.3 miles down a mountainside. Number 5. Pyroclastic flows. Imagine a cloud of hot gas and ash rushing down a volcano at over 100 kilometers per hour. That's a pyroclastic flow, and it's one of the most dangerous things that can happen during a volcanic eruption. Pyroclastic flows are created when the hot gas and ash from an explosive eruption meet the cold air outside the volcano. This causes the gas to rapidly expand, creating a powerful blast wave that rushes down the volcano. These flows can reach temperatures of up to 1,000 degrees Celsius and can travel for tens of kilometers, destroying everything in their path. During the eruption of Mount St. Helens in 1980, a pyroclastic flow killed over 50 people and destroyed hundreds of buildings. Number 4. Lahars. Lahars are volcanic mudflows that happen when hot magma mixes with water. During an eruption, water from rain, lakes, or rivers can mix with the hot magma and create a thick, sticky mud called a lahar. Lahars are fast and can travel for tens of kilometers, carrying debris and destroying everything in their path. For example, in 1985, a lahar from the eruption of Nevado del Ruiz in Colombia killed over 20,000 people. Number 3. Volcanic tsunamis. If a volcano erupts underwater or near a coast, it can cause a tsunami. These are giant waves that can travel across the ocean at speeds of up to 800 kilometers per hour. The 1883 eruption of Krakatoa in Indonesia, for example, caused a tsunami that killed over 36,000 people. Number 2. Volcanic winter. When a large volcano erupts, it can block out the sun. The ash and gas can stay in the air for months, blocking sunlight and cooling the planet. For example, the 1815 eruption of Mount Tambora led to the year without summer in 1816. The average global temperature dropped by about 0.5 degrees Celsius, and there were widespread crop failures and famines. Number 1. The Yellowstone supervolcano. The Yellowstone supervolcano in the United States is one of the most powerful volcanoes on Earth. It's so big that if it erupted, it could bury much of the western United States in ash. In 640,000 years, it's had 3 major eruptions, each one bigger than the last. Scientists are constantly monitoring it to make sure it doesn't blow its top anytime soon, because you know what happens when a supervolcano erupts? Everything changes. Lava, ash, hot flows, poisonous gases, and volcanic winter. Eruptions may shape the world, but they are truly nature's ultimate show of force. They are beautiful, terrifying, and awe-inspiring all at once, and yet they continue to fascinate us. Maybe it's because they remind us of the awesome power of the natural world, or maybe it's because they are just plain cool. Whatever the reason, volcanoes will continue to capture our imaginations for centuries to come. Thanks for watching. See you next time.